Hello, everyone. Thank you for coming. I'm going to be talking about Travis CI and testing Django today. So if you want to look at the slides, you can follow that link. I've put all the slides up there on speaker deck, so you can check them out, or you can just watch up here. They're the same thing. So a little about me. I'm a Python developer at Adventures. You can find me on Twitter at Adam McKerlie, or pretty much everywhere else at Silent One Mezzo. So just an overview of the talk. First, a few definitions. Then we're going to have why you should test your code. Everyone should test their code, so here's why. What parts of your code should you test? And then writing your first test, and that'll just be a couple slides about Django testing. And then we're going to wrap it into how you can integrate your tests into Travis CI and how to run them automatically. So kind of two parts. The first part is testing, and then the second part is Travis CI. So first, a few definitions. The first is unit test. Basically, a unit test is kind of the smallest section of code that you can test. It's generally just a small functionality. It's not a large test that covers the entire stack, but it's just basically the smallest section of code. What unit tests often do is they help you focus your code. If you have a giant view or a giant function, they help you break it out into smaller chunks of code that you can then test. They're also fast. Because they're so small, because they generally are small chunks of code, they're very fast. Integration tests, function tests, whatever you want to call it, these generally test large functionality of your program. So in Django, there could be a view or a form, middleware. They're slow, often slower, because they're going through the entire stack of your code. They're going through your middleware. They're going through your URL router. They're hitting outside services, so they're often a little slower than unit tests. But they often give you an entire picture, a full picture of what's happening. Because you're hitting outside services, you're going through routing, you can find out issues that you wouldn't have found out through your unit tests. So why should you write tests? And I've had this question where all right, they've written this awesome application, it works, but why should you write tests? It gives you confidence in your code. Because you know that you most likely have tests for your code, it allows you to be able to not have regression bugs, or it allows you to have more confidence in what you release. If you're constantly releasing new stuff multiple times a day, tests can give you that confidence to make sure you're not releasing something that breaks something else. It allows you to iterate faster. It allows you to develop faster. It just allows you to code faster. It provides beginners an easy spot to code dive. I know whenever I come to a new piece of code, I always go to the tests first, just because it gives me an idea of seeing what's important, what's well tested, and sometimes where I should look at to first, because maybe it's prone to breaking. Finally, untested code is expensive. If you don't know what's going to break, you can worry about it. You spend more time trying to debug, and it just becomes more expensive from a development standpoint, and from a business standpoint. I'm sure most of you have seen this quote. It's a fairly popular one, but code not tested is broken by design. You should all have code or tests for your code. If you don't, go write some. Honestly, even if it's just a test that makes sure that your view returns 200, it's better than nothing. So what should you test? First, don't test stuff that's built into Python or Django. It's used extensively. It already has tests. In most cases, unless you're doing something really, really crazy, you can just assume that it works. What you should test is the stuff that you write. You should test your views, your models, your forms, your middleware. Stuff that you've written, that's what you should test. So now we're going to go into testing making your first test. If you've already done testing in Django, you should probably recognize this stuff, so I apologize. Tests generally go in either models.py or test.py. Sorry, they can go in either one of those, but in general, they should go in your test.py module. This is your basic test. You can see here, you just import a test case. You have a method that's test underscore certain name, and then you do your assert. In this is a pretty trivial example that's bundled when you create a new app, but here it just asserts that 1 + 1 = 2. And then finally, to run your tests, you just do Python manage.py test and then your app name. If you leave out your app name, it will just test all of the applications in your installed apps. So like I said earlier, if you just want to start testing, just make sure that every view has a test like this. So this could be your test if you have a blog app, you're testing that your index page returns 200. There's nothing complex about this. All it is doing is it's just making sure that you don't have any syntax errors, that it goes to your views. You can get a lot more complicated. The docs, Python docs or Django docs for this are really good, and there's tons of information out there on the web about testing. But this is the basic syntax of it. So if you want data into your tests, there's a few ways to do that. One of the ways is to use fixtures. A fixture is just serialized data that you can load in whenever you're running your tests, and it gives you the ability to have basic models, just information that you need to test on. You can do it by dumping data from your database. You do that by Python manage.py dump data, the app name, and you just pipe it into a JSON file. And then you include it by just having the fixtures, and it equals the file name. Some warning here, fixture names are global, so if you have them, just be careful with having like the same name. This is what it looks like. It's just a serialized dump of the model. You can see the model name or model type, title, body, slug. This is just for a basic blog post. So when should you test? Personally, and this varies per person, but I think you should test after every commit. If you are committing, if you're committing code, probably test it. It's probably important, and you should make sure that it doesn't cause any regression tests or regression bugs. Sorry. Obviously, again, your code flow will vary. Before you merge into branches into master, I think this one's really important. Especially for my team, we always try to keep master deployable and stable at any time. So it's really important to make sure that when you have a feature branch or a bug branch, that you merge or you test before you merge, just to make sure that you're not creating issues in master. Once you've deployed code, now often people will test before they deploy code, and then they just forget about it. But what I've found is that there's often issues once you've deployed code where there could be performance issues that you just don't notice in your dev environment. There could be just weird configuration changes that you have. So I think it's always a good idea to test after you've deployed your code, even if it's just a performance test to make sure that pages aren't loading any longer. There's not a massive number of queries that have been added. Now, if you're testing all of these, it can be unwieldy at times. You're testing a lot. If you have a large test suite, that can be really expensive. It can take a long time. And that's where continuous integration comes in, where it runs the test automatically instead of you having to run it yourself. That's also where Travis CI comes in. So what Travis CI is it's a continuous integration testing tool. It's hosted. They're also on GitHub. They're open source, so you can download it yourself, install it yourself. And that's where you can find it. It's the only meme, I promise. It's nowhere else. So how does it work? First, you need a GitHub account. Travis CI uses your GitHub repositories. So what you do is you specify the repositories that you want to test. It's very simple. You just toggle the repository that you would like. You include a travis.yaml file in your repository, and I'll talk about that later on. You carry on with your normal flow. You change code, commit it, push it. And then Travis will run the tests automatically, and they'll inform you whether they pass or not. Now, this is what Travis looks like. This is the configuration page where you can specify which repositories that you want to use. You can see here on the right that it's just a toggle. You toggle which ones you want to test. This is what your travis.yaml file looks like. You should have this at the root of your project. And basically, there's a few things here. The first is that you define a language. Obviously, I'm using Python. We're testing Django. You can do Ruby, PHP, Go, JavaScript, C. There's plenty of different things you can test. Next, you'll see the language or the versions of Python that I want to test. I think by default it's 2.5, 2.6, 2.7, and 3.2. So you can test any version of Python that you want. After that, you'll see that there's the install. And basically what it's doing is the first line is just installing from my setup.py file, and then the next is installing all of my requirements. And what Travis does is it basically fires up a VM, runs through all of your requirements, installs all of your dependencies, and then it runs the test. And the final line there you can see is the script, and that's where it will run the test. You can use manage.py test, nose test, basically whatever you want. If you have a bash script, you could run it. However you want to run your test, it allows you to run it there. So a few cool things that you can do is you can have different environment variables. If you want to test different versions of Django against different versions of Python, you can do that. What Travis will do is it just creates a matrix of all of the different options. So in this case, it'll test Django 1.3 against all of those versions of Python, and then 1.4 against the same. So you just do it by setting up the environment variable, and then you install it in your requirements. If you want to use databases, you can too. If you have Postgres, MySQL, it also handles SQLite and MongoDB. But again, you just specify which ones you want installed, and it will go and install them and test them against all the different versions of Python and Django. So it's really great. You can install a lot of different things and test against a lot of different things. I think probably one of the biggest features from my perspective is that it tests against pull requests. So what it does is, once you've done your pull request, it will merge your pull request into the branch that you want to merge it into behind the scenes. It will then run your tests against that merged pull request, and then it will notify whether it's passed or not. So here you can see in GitHub, you'll see that it's determining merge status. You know when you have your pull request and it says, oh, you're able to merge it. Well, here it now says that it's determining the merge status, and that's where your Travis tests are being run. And then if it successfully passed, it tells you. It's like, OK, all the tests have passed. You can now merge it successfully. This is what an application would look like. This is just one of my applications. Some information here. You can see all of the different builds. You can see when it was last built, how long it took, the different, whether it was successful or not. This is a specific build page. So each time you run your tests, after every pull request, after every push, you'll have an individual build page that'll just basically show you all of the information. It shows you like who committed it, what the commit message was, when it was, how long the test took. And then in the section down there that was cut off, it basically goes through and just does an output of your entire setting up the VM, cloning the repository, cloning installing all the requirements. And it also gives you all of the output to your tests. So if one of your tests fails, it'll show you there, and you can see what happened and why the test failed. Some other things you can include, you can have a before script and after script. What this does is it does stuff that before your tests are ran and after. Some of the things you can do here are setting up databases and loading data, running reports. If you have any Git hooks, you can do that. So that's pretty powerful. Notifications. Another great thing is that if your tests fail or if they pass, you can set different notifications in what you want to happen. So the first one is email notifications. After every test, you can be emailed if you want. After every change, if they succeed or fail, you can specify which emails you want notified. IRC. I know my team often works in IRC. So if you want to be notified in your channel when your tests pass or fail, you can have that as well. Webhooks. If you have set up your own domain, you want to just be notified whenever something happens, you can set that up. You could even tie this into an automatic deployment where if they pass, you'll do something on the back end and deploy your code. So just a few final tips. If you want to skip a commit, if you don't want to test after a certain commit, you just add CI skip into your commit message, and Travis will just ignore it. If you have a README, and again, this is really good for like open source. But if you have your README, you can add in this image that will tell your users whether the build is passing or not. So obviously people know whether to download it or not. Travis lint, for testing your travis.yaml files, I didn't know about this at first. And the way I went about doing it is just doing fake commits and hoping that it worked. But now you can test it before you even do that. So you just run travis.lint on your travis.yaml file, and it'll tell you whether everything works or not. And that's it. So thank you. Does anyone have any questions? We have 5 minutes left. Cool. No? All right. So yeah, you can view the slides. I tweeted it out. And if you have any questions afterwards, I'll be around. So thank you very much.
Thank you, Adam. We'll now take a short break, and after that, we'll be back in the main hall at 3:45 for the lightning talks. Thank you.
Hurry? Yep, sure.